In this question, it is given that a brass scale of barometer gives a correct reading at 10 degrees Celsius. The barometer reads 75 centimeter at 30 degrees Celsius. What is the atmospheric pressure at 0 degrees Celsius? The coefficient of expansion of brass and the real coefficient of expansion or the value of gamma of mercury are given. So this question is somewhat difficult. It is mixing of many concepts. So just try to understand this question. So for that purpose, first we should know how we are measuring the atmospheric pressure by using a device known as nothing but barometer. So barometer is a device which is used for the measurement of atmospheric pressure. For the measurement of atmospheric pressure, what we'll do is we'll have take a container which consists of some amount of mercury in it. Then we'll take another container or a test tube which consists of mercury, and we'll put this one inside this. So what will happen is, because of this weight of mercury, some amount of mercury column will come down. Now the level of mercury inside this container will decrease and it will attain a particular height. Let's say after some times the height of mercury column inside this one becomes equal to, take it as h. Now from this I can measure what about the value of atmospheric pressure. We'll say that atmospheric pressure is equal to h height of mercury column over here. Now in this question, this mercury column, the height of this mercury column, we are measuring by using a meter scale or any centimeter scale. Let's say a centimeter scale, something like this. But this centimeter scale is made up of brass, so that due to thermal expansion, there will be some expansion is happening to mercury as well as expansion is happening to this brass rod. As an example, assume that initially this brass rod was showing a reading of, let's say, as an example, we are considering a reading of, let's say, 4 centimeter, as you can observe in this diagram. Now assume that due to thermal expansion, the size of this brass rod is increased, means the scale is increased. Then it will look something like this. You can just observe that I'm just increasing the size of the scale. So what will happen now is this, it will not show a reading of 4, now it will show a reading of 3.5. got it? So the whatever the measurement that we measured by using this scale, it may not be correct. So that's why in question it is mentioned that the brass scale of a barometer gives a correct reading at 10 degrees Celsius. At 10 degrees Celsius, this brass scale is going to give the correct reading, and the barometer is 75 at 30 degrees Celsius. That means the reading 75 is not the correct value. At 30 degrees Celsius, it is going to show some wrong reading. That wrong reading is 75 centimeter. So first of all, we need to identify what about the actual height of mercury column. So let's see how we'll identify the correct reading if there is some thermal expansion is happening to a scale. So just try to observe that part also. Suppose if you are having a rod something like this, and if you would like to find out the length of this rod, assume that this is representing its correct temperature, or there is no expansion in this brass rod, so that this length is exactly equal to, take it as 1 centimeter. So by using this scale, we'll measure the length and we'll say that now the length is equal to nothing but 8 centimeter. Now let's see how we are getting this 8 centimeter. We can write it like this also. That is length, whatever may be the value of length over here. So we can write this reading will be equal to length of this rod L divided by what is the length of 1 centimeter, or what is the length of 1 unit. Then that is going to give the value of its reading. That means a reading over here is 8 is equal to 8 centimeter divided by 1 centimeter. So I'll get the reading is equal to 8. So you can say that the reading, just remember this formula, that is a reading by using any scale is equal to what about the actual dimensions, or what about the actual length divided by what do you mean by 1 unit. Now at 30 degrees Celsius, the length is given as nothing but 75. In question, you can observe that is given as 75 at 30 degrees Celsius. So we can write that is 75 is equal to length at 30 degrees Celsius divided by, so that is going to give the actual length at 30 degrees Celsius divided by what do you mean by 1 unit. So 1 unit is nothing but 1 centimeter. Initially it was 1 centimeter. Now due to thermal expansion, the cause in question is given that it is giving correct reading at 10 degrees Celsius. Now the temperature is 30. So we can say that there is an expansion due to 20 degrees Celsius. So now the 1 unit, initially 1 unit was something like 1 centimeter. Now, and take it as initial length was L0. Now both are changed. Length is increased as well as this 1 centimeter is also changed. So we can write the value of 1 centimeter becomes, we can take it as it is nothing but L0 into 1 plus alpha delta T. So we can write length of mercury column at 30 degrees Celsius, and 1 centimeter becomes equal to, we can take it as 1 centimeter into 1 plus alpha of this brass rod into delta T. So we can write this, what about the actual length at 30 degrees Celsius? So we can write the 75 as equal to length at 30 degrees Celsius divided by 1 plus the value of alpha is given in question. In question, the value of alpha is given as 20 into 10 raised to minus 6. So we can write this as 20 into 10 raised to minus 6 into delta T. The value of delta T, we can take it as it was initially 10, now it is 30, so it becomes equal to 20 degree Celsius. So we can find out what about the value of this L at length at 30 degrees Celsius. So that is 75 into this value, which is 1 plus 0.0004. So we can write this length at 30 degrees Celsius will be equal to 75 into 1.0004, which is equal to 75.03. So this is the actual length of mercury column at 30 degrees Celsius. Now we can identify at 30 degrees Celsius if it is showing 75.03. What about the reading at 0 degree Celsius? So we can just consider that pressure exerted by a liquid column, we'll find out by using this equation H into rho into G. Now the atmospheric pressure is not going to change. Atmospheric pressure is a constant, but due to increase in temperature, density of mercury changes. So this equation can be written as height of mercury column, let's say at 30 degrees Celsius, into density of mercury at 30 degrees Celsius into G will give the value of atmospheric pressure, and which is not going to change. So that we can write same value for at 30 degrees Celsius, same atmospheric pressure. Atmospheric pressure is not going to change, but the reading on that barometer is going to change with respect to thermal expansion. So we can take it as height of mercury column at 0 degrees Celsius into density of mercury column at 0 degrees Celsius into acceleration due to gravity. Now our aim is to find out what about the value of height of mercury column at 0 degree Celsius. So we can cancel this G. So we can write height of mercury column at 30 degrees Celsius into density of mercury at 30 degrees Celsius divided by density of mercury at 0 degrees Celsius will give the value of height of mercury column. So we can write height at 30 degrees Celsius into density at 30 can be written as density at 0 divided by 1 plus gamma delta T, and divided by density at 0 is equal to height at 0. So we can cancel this density at 0 and density at 0. So we are going to get the value of height at 0 degrees Celsius is equal to height at 30 degrees Celsius divided by 1 plus gamma of mercury into delta T. Now height at 30 degrees Celsius we already calculated, and it was something like 75.03 divided by, we can write 1 plus the value of gamma of mercury is also given, that is around 175 into 10 raised to minus 6, and the value of delta T is nothing but 30. So if you are putting this value, we'll get as around 75.03 divided by 1 plus 0.00525. So you can write height at 0 degrees Celsius, or actual height at 0 degrees Celsius is 75.03 divided by 1.00525, which is equal to around 74.6.